Continuing on with our investigation into the collapse of the Champlain Towers South condominium in Surfside, Florida, NIST, who is the government agency in charge of the investigation, has given us a recent update on their investigation, along with some upsetting and bad news. Now, these meetings actually occurred in September here of 2024, but unfortunately I couldn't get to them in time because I was so busy uploading all of those videos for you on the OceanGate Titan submersible, which hopefully you saw some of those videos because I was quite busy doing a bunch of them, because that's when the Coast Guard hearings were taking place, where they were bringing to light a whole bunch of new evidence and videos and testimony on the OceanGate Titan submersible. So after you watch this video, you're going to want to binge watch all of those. So this is the machine that they use in the engineering lab that will put the rebar rods into tension and pull them apart. This is how they test the strength of the bars to make sure that everything's okay, or to see whether they met the design constraints or not. So here they are, they pull them out of the case. This is how they got them from the actual Champlain Towers South condo collapse site. So every piece of evidence that they've pulled out of that site has been photographed, cataloged, weighed. They know exactly what everyone looks like. And every piece that they've pulled out of there is also digitized, so they can look at it individually on the computers in all different angles and everything. And so here what you're going to see is they're going to paint the sample of these rebars that they're testing. The reason why they paint them, and you'll see them add some black specks on there later, is to help them differentiate the areas where it's going to be torn apart when they break this bar under tension. So it just helps them identify where it was, the area that broke. So you're going to see that once they put this on the machine there. So now they do everything. They measure it. They want to know exactly everything before they run the test, and they're going to remeasure everything after they run the tests as well. They want to characterize these rods. They want to know how much did they stretch, how much did they move. They want to be able to calculate their Young's modulus of elasticity, and they're counting all of the threads there. So now here comes the actual testing of these rebar rods. So what they do is they'll stick them into the machine there, and they'll clamp them down at the top and the bottom. And this is a very powerful machine that's just going to pull from both ends of this rebar rod until it breaks. And that's what they're doing. They're going to characterize how strong are these metal rebar rods, and were they up to snuff here. And now they're adding a sensor on there. You can see he's putting it on there. That's likely a strain gauge that's going to tell them how much that rebar rod moved during the test before it busted. Okay, so there you can see on the screen on the lower right there, see it says 1,400, 1,600, 1,900. That's how many pounds, that's how many foot-pounds there were there. And then it graphs the results there on the screen so they can see pretty immediately what's going on there. And then watch, you're going to see it break any second here at the lower end of the rod. See, you're zooming in there and watch, boom, right there. See how it just broke? So you can see why they want to paint it. It just makes it easier to see that spot where it happened. And there it is from another angle when it breaks, boom. So you can see why, people always wonder, why does this testing take months and months and months and years and years? Look at all of the work they have to do just for one piece of the puzzle. And there's many, many pieces of the puzzle that they have to do this work on here in order to get a good feeling for how good were the rebar rods that were used throughout this entire construction project when they built this Champlain Towers South condominium there in Surfside, Florida. So now that the testing is done, they're taking more measurements on it because they want to characterize what happened to it afterwards. How well did it fare? How well did it not fare? They want to look at the quality of the metal. They'll look at the cross-section. They'll look at everything on there. So the work is, it's very slow going. When you have to be this precise, it's just like when there's a plane crash, right? And they get all of the parts of the plane and they put it in the hangar. But however, they have told us numerous times on this project here for the Champlain Towers South condo, for this investigation, they've invoked some of the most incredible databases in the history of doing engineering analyses.
My name is Fahim Sadek. So I'm a structural engineer by background, and my expertise mainly is in computational modeling of structural systems. And this expertise we are bringing into the investigation into the collapse of the Champlain Tower South. From my perspective, the hardest part of this investigation is to figure out what is the collapse or failure initiation mechanism. Basically, there were two measurements that are critical for our investigation. The first one is the compressive strength of concrete. And by taking these cores or these cylinders and squashing them, we are able to measure the ability of the material to resist the loads imposed upon them. The second was the modulus of elasticity. Basically, that is a measure of the resistance of the concrete material to deformation when they are under load. This data is crucial for the computational modeling for the analysis that we are doing of the collapse mechanisms. Personally, this investigation is one of the highlights of my career, trying to figure out what happened, how to avert that in the future, and I'm sure with the team that we have here, we will be able to figure it out for sure. It's what we are made of at the NIST, to go after these mysteries and resolve them to the best of our abilities.
Now, we did get some bad news here, and that is pretty stunning here, that the investigation has suffered some technical and some personnel setbacks. And so they're going to be delaying the report now for another year, about 11 months, deep into 2026, unfortunately. It was originally supposed to be ready in 2025.
And the CTS program has had difficulties and setbacks. As we peel back more layers of the onion, new realizations appear that must be pursued, but they lead to greater understanding in our analysis of evidence. One example of surprises is in test results. Literature for Frankie pile foundations, such as those used in CTS, requires a minimum compressive strength of the pile concrete to be in excess of 3,000 psi. While the average of recent tests of samples extracted from the CTS site was above 3,000 psi, some core tests were significantly lower, as low as 1,700 psi. Now, we've previously reported that the geotechnical karstic features and the differential foundation settlement scenarios were very unlikely contributors to the failure, and we still hold that preliminary evaluation.
Yeah, so here's some of the challenges that they found too, like some of the concrete had low strength test results. So they were finding that some of the Frankie piles, which are the columns that are under the foundation, that some of them may have been made with a little bit lower PSI rated concrete than they should have been. Now, does that mean the building is going to collapse? Well, we don't know. I mean, it did stand for 40 years before it did collapse. But at the end of the day, when they're done testing, they'll let us know whether that had any effect at all on the stability of this building. Yeah. So on their program management timetable here's where they're showing how it's affecting everything. So originally, if you look right up here, the March 2024 estimate for the release of the draft report was supposed to happen already here, but it's going to add 11 months to that, and it will actually be, but the completed technical work won't end until May of 2025, see? Then you have the level 1 report as in October of 2025 here. See where that arrow's pointing right out to here. And then the final draft report released will be April of 2026. So there's that 11-month addition of time on there. Just since March 2024, just so between March and September of 2024, they collected another 187 cores out of the concrete in addition to what they've already done, the hundreds that they've done up until now. And so they have 235 testable samples, and they've done 593 tests for mechanical properties of concrete so far. And they've done 183 tests for the reinforcement steel, like I showed you here before. And they completed forensic analysis of the hard drives, and as you know, they were not able to recover any useful data from them. But they did identify additional security cameras in proximity to CTS, so we'll see where some of these other ones are here and whether they provide anything useful for us. Now, this here is what's truly mind-boggling. There's 15,000 images and videos tagged into the Griffey, I think it's called the Griffey database. So this is what a lot of government and investigative institutions use because of its thoroughness, and you can just put so much metadata with each picture or video. This provides them with a great way to cross-reference virtually any piece of evidence they have in their possession. And this is probably a lot more than has been done in some of the plane crashes and stuff too. And then, of course, here's an image of the LiDAR of the south basement wall right here. This is the hole in the pool deck leading down into the garage. So you're looking down inside the garage. The pool is right here, and then the wall is here. So you can see part of the wall's already been removed by this point. Right here, it says right here, they've already done 300 petrographic, chemical, and durability-related property tests of all of the structural concrete. And, you know, make no mistake about it, folks, they're not ignoring the soil either. So they're doing soil structure, computer simulation as well. The pile, core strengths, they've been testing all of them. And here's some other photos from different angles here of those structural tests I was showing you, where they were here busy duplicating that pool step up to the first floor slab. So right here, this vertical point right here is where the southern wall of the condo was, right at this step up. And they're doing more slab column testing over here. And all of the accuracy of all of the testing and everything they're doing, and they combine it with the critical shear crack theory, they're using this to feed their finite element models that they're going to test on the computers. Billions and billions of bytes of data, and also scanned and photographed as it sits in the warehouse. Here you can see the U-Haul trucks that were still bringing in more pieces. Here's the mechanical testing that they were doing on the cores of the concrete, and more here on also the rebar rods. And also remember, part of their delay over the summer was they waited about 6 weeks after the 3-year anniversary of the collapse, which was on June 21st, before they picked up again. So they ramped back up again, and they relaunched the interviews here in July and August. They completed the column tests and the mechanical tests of the concrete cores, and they started to do their first beam slab column joint tests. So that was probably the real difficult one for them to set up, and to get those, for example, the step up from the pool deck to the first floor slab there, to get all of that done correctly, and evaluated the hard drives, in which they reported that unfortunately there was no useful data on those hard drives. Yeah, so here's some of the structural tests that they were running, and here's the equipment that they were using. And see, here's the slab that they did here. Here's the step up from the pool deck to the first floor slab right here. So they had this, and here's your beam A that's on there. So they had this entire thing constructed and supported, and they're performing their testing on it. The drawing over here on the left actually shows it a little clearer for you. And here's more views of different structural testing that they were doing. And by the way, NIST is still putting out that urgent call for data or any information that people might have, old photographs, anything that would help in their investigation. So here's where NIST explained why they're going to be running about 11 months behind now. So where we originally were expecting to have a report by like June 2025, it's now going to be in 2026, which has got to be heartbreaking for the families. But here's part of the problem here. Is right here is this time and working through challenges of this complex, large-scale test program, especially doing these slab column connections. And then in the geotechnical program, they lost key technical staff member, which took them a while to replace that person who was doing all of this work. And then in the social sciences, they had to, it says right here, see, extended time required to customize the interview instruments for each stakeholder and to have them approved. And then right here, see, they paused, like I mentioned before, they paused for 6 weeks surrounding the collapse anniversary. So they weren't doing any interviews with people during that time out of respect. And then they also had to go to different local governments for all of their records, for the archival and research and everything. So this right here is your main answer as to why we're seeing now an 11-month addendum of time onto the total investigation time frame. So the problem that they're facing right now here is they have to duplicate all of this concrete from the Champlain Towers South condominium building site there, the as is, or the as built version of that concrete. So in order to do that, you can't just go down to Home Depot and buy a bag of concrete and mix it up and start doing your testing. They have to take concrete and make it themselves from the same materials that they did back in the day with the same small pieces of aggregate rocks. Everything has to be exactly the same. And the PSI has to come out the same. And then you have to wait 30 days for it to cure as well, right? So you can't just go to Home Depot, mix up your bag of concrete, and then voila, start testing. Everything has to cure. So this is probably what's adding on to a lot of their time. And sometimes they miss. So they'll mix up their batch trying to get it as close as possible. And they'll find out, oh, it's not quite the same analysis. They'll take a core sample and they'll go, you know what? It doesn't quite match the building. The PSI rating is off. And what complicates matters even more is in some spots of the Champlain Towers here, you have these columns, right? And they go through the slabs. And sometimes the PSI rating of the concrete in the columns was, say, 8,600, but then maybe 4,600 PSI in the slab. And it really shouldn't be that way. So now you got to try to mix and match and get that to come out exactly the same. The slab over here is about 4,400 PSI, but the column down in the basement is over 8,000. And it's more of an art than it really is a science. You have to keep making batches and let it cure and then test it and try it again and go back to the drawing board. So you can see why this is just taking up so much time for them right now. So I will let you know when NIST gives us more updates here on the Champlain Towers collapse. And in the meantime, make sure to start checking out and binge watching these videos here that I uploaded for you on the OceanGate Titan submarine implosion. And then don't forget to check out this video here on that awesome double-decker kitchen installation that I did there with the cabinets and the refrigerator in the 45-degree angle. So thank you so much for joining us, and we'll see all of you on the next one.